Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about one sample confidence intervals for a proportion. Before we get started, I want to take a minute to talk about Florence Nightingale, who lived from 1820 to 1910. And she's famous for her medical efforts as a nurse. But did you know she also invented a specific type of statistical graph called a coxcomb, which she used during the Crimean War to track different types of diseases and injuries for soldiers? Now let's say Mr. Morehouse wants to estimate the proportion of students who eat breakfast before school. He obtains a random sample of 45 high school students and finds that 18 of them usually eat breakfast before school. Mr. Morehouse wants to create a 95% confidence interval to estimate the true proportion of high school students who eat breakfast before school. Step one of our confidence interval procedure is going to be to state the parameter. We're going to say let P equal the true proportion of high school students who eat breakfast before school. Step two is we're going to plan the inference method and check the conditions for that method. So we're going to do a one sample Z interval for P here, or you could also say a one proportion Z interval. We have three conditions. The first one is that there's a random sample of students, which was stated in the problem. We're going to state that the 10% condition is met and show the work for that. Now, while we don't know the total number of high school students, we can assume that there are more than 450 students in the high school. And then finally, the large counts condition. We're going to state that it is met, and we're going to note that there are at least 10 successes and failures in the sample. The next step is to do the calculations. Here we have our formula for a one sample confidence interval for a proportion. We have our point estimate P hat plus or minus, and this whole second part here is our margin of error. This margin of error is composed of our Z star critical value and the standard error of the sampling distribution, which is this square root part of the formula. If we were going to do this by hand, we would say, okay, our P hat would be 18 successes out of 45 in the sample, so 0.4 is our point estimate. We would then take our 0.4 and plug it into the formula along with our sample size of 45. The critical value for a 95% confidence interval would be 1.96. So we would plug that in for our Z star and then crunch some numbers, and we'd get just around 25% to 54% for our confidence interval. Now, if we wanted to do this using Desmos, let's jump over to Desmos for a second. We could go to our inference procedures here, and we're doing a test for proportions. Now, I know it says test and we're doing an interval, but this is where you do tests and intervals. And so we're just going to go ahead and select Z test for proportions. It asks for the number of successes, which was 18, and the sample size, which was 45. And then we're going to hit create test. Now, over here on the left-hand side, you can see that it has Z prop test with the number of successes and the sample size put into the parentheses. And it gives us two drop-down menus, confidence interval and significance test. So we're doing a confidence interval, so I'm going to drop that down. I'm going to verify that the confidence level is the level that we want, which was 95%. And so that's already good. And then it gives me the endpoints 0.257 to 0.543, which is what we got by hand as well. So this is how you can calculate the interval itself using Desmos. Jumping back to our slides, after we calculate the actual interval, either using the formula or using Desmos, the last step is to conclude by interpreting the interval in context. So we're going to say that we are 95% confident that the interval 0.2569 to 0.5431 captures P equals the true proportion of all high school students who eat breakfast before school. It is important here that we list out the confidence level and the interval, and then the proportion is given in context, and we state that it is a parameter or a population level value. I've done that in three separate ways in this interpretation. I have the P equals because P is the symbol for a parameter proportion. I put true proportion, which also indicates that it is a population level value, and I've said of all high school students. Now, you don't have to do all three of these, you can do just one, but I wanted to demonstrate the three different ways for you on this one, so I put them all in there together. Thank you for watching this video. Have a great day.